Okay, we have some half-angle trig formulas up next, and it looks like they're all kind of like delineated out on the left here, and we got some special sets of rules over here that we're going to touch on probably in the next video when we start using these to evaluate. For right now, let's take a look at some of the proofs behind these guys. So what we're looking at is the way that these are commonly proved out. And it sounds like a kind of a bizarre first step, but we start off by using the cosecant, I'm sorry, not the cosecant, the cosine double angle, okay, where we know that this is going to be cosine theta minus sine theta, okay? And that seems a little bit bizarre to start off with, because it seems like, well, it doesn't really have anything to do with that. So, but if we go ahead and start to build on this thing, you're going to see why starting off with a double angle is going to make sense. So the first thing that we're going to do is that I notice that I want to have the half angle of sine. So what I want to do is that I want to make this cosine right here. I'm going to use the Pythagorean identity, and I'm just going to put it over here in this part. And I know that cosine squared can equal, if I subtract sine squared from each side, it's going to give me 1 minus sine squared. So I'm going to replace that and write it like this. And now we have our new line that is on the right hand side sine, and on the left hand side cosine to theta. Okay, so what I'm going to do is I'm going to gather up some like terms, and I'm going to go cosine to theta, and I have on this side 1, and I have 2 negative sine squared thetas, so I go negative 2 sine squared theta. And now what I want to do is get sine squared theta all by itself, okay? So I'm going to subtract 1, okay? And I'll show all the steps on that. So I subtract 1 and divide by a negative 2. So I got sine squared theta is going to equal, so I got cosine 2 theta. I subtract the 1 and divide by a negative 2. Okay, so we can see, though, if we look up here, that this is switched around. So what we do is that we take the negative, we're going to multiply the top and the bottom by a negative to get that switched around, okay? So we'll go top and the bottom by a negative 1, and now I'm going to run out of room here, so give me a second to clear this. Okay, and I have this guy, all right? And so I'm going to have to infiltrate into the next column here. Hopefully you can fit it better than I can, because I have to write large. And what I'm going to do is that I'm going to take the square root of both sides to get rid of that square. And remember, when we're taking the square root of both sides of something that basically we have to do a plus or minus when we're undoing a square like that on the right hand side. And so we end up with this business of sine theta equals plus or minus the square root of 1 minus cosine 2 theta all over 2. Okay, and now the final part is this, is that we're going to, instead of leaving that as just a theta sign, we're going to put in a theta divided by 2. And the reason being is that whatever we put in here, like say if I put a 5 in here, a 5 would be right here. Okay, whatever value that I'm going to put in for theta, it's going to appear on the right hand side. So what we're going to do is that we're just going to drop in a half with that, and it's going to go the sine of theta divided by 2, okay, plus or minus, and 1 minus, let me clean that up a little bit, 1 minus cosine of 2 times theta divided by 2 all over 2. And you can see that the 2's cancel out. And at the end of the day, we're going to get the final version of sine of half theta, or theta divided by 2, plus or minus 1 minus cosine theta divided by 2. Okay? And so that's how you would how we derive them out, and these are the most common forms that you'll see. What I want you to do is, in that vein, starting with this step right here, see if you can derive that. So pause the video and give it a try. Okay, so there it is, and hopefully that the magic move, if you will, is to go ahead and change this sine, because we're trying to get cosine eventually all by itself, to, using the Pythagorean identity, to this guy right here, and then you follow the same steps and it just kind of falls apart from there. Let's take a look at this tangent proof. Okay, I had to erase some stuff to make some room here, but what we're going to do is that we're going to capitalize on our sine and cosine identities there, the formulas, and we're going to go the sine of, let's see, use the definition of tangent, which is sine over cosine of whatever angle that you're taking, and we're going to land that first, okay? Then we're going to plug in these identities. It seems like it's going to get out of control real quick, but it's really not. It's not too bad. So when we stack them up, this is what it looks like. Okay, and extending the square root sign, because remember, is that no matter what, if we take the square root of some number and divided by the square root of some number, we can write it as 1 square root of the entire fraction. So I'm going to do that. Okay, and then I'm going to simplify this yucky looking radicand. So it's going basically it's going to invert the bottom, flip it, and then multiply. The 2's are going to cancel out, and we'll end up with this guy. Okay, and then we're going to do something kind of tricky here, and we're going to multiply the top and the bottom. And what I'm going to do is that I'm shooting for this guy right here, which is going to be this guy. So I'm going to go ahead and shoot for the sine on the bottom and the 1 minus cosine on top. So I'm going to multiply the top and the bottom by the square root of 1 minus cosine theta, like this. All right, and so what is going to happen is something kind of neat. When I multiply these two together straight across, I know that when I have the square root times the square root, you're just going to get the radicand if it is going to be the same under there. So since 1 minus cosine is the same, I'm going to get 1 minus cosine. I can drop the square root sign, and I end up with that on top. That's good. So when I still have on the bottom, if I multiply those two together, I'm going to get this business of 1 minus cosine squared when I do these guys right here, okay? And so I know that 1 minus cosine squared, if I'm looking at the Pythagorean identity, that's going to be sine squared plus cosine squared equals 1. And so it would follow that sine squared equals 1 minus cosine squared. So I can replace that with just sine squared on the bottom. So I got 1 minus cosine theta all over the square root of sine squared theta, which now when I take the square root of that, I am going to just get sine. And so at the end of the day, I end up with 1 minus cosine theta all over sine theta. and it looks like we got it. Okay, this guy right here. And so we are done proving those out, showing why they work, and let's go ahead and take a look at how they work in the next slide here, or in the next video. Okay, so here we have some uses for the half-angle formulas here, and we're going to start off with sine. And we notice that we have pi over 8, and we're like, what is that all about? But one way that we can rewrite this is the following, okay? So say if I have, I want to rewrite this as some angle divided by 2, okay? And so if I set this equal to pi over 8, and then I solve, I put the 2 over here, and I end up with theta equals pi over 4. Okay, so that's pretty interesting. So the way that we want to rewrite this then is going to be the sine of pi over 4 divided by 2. And the reason why we want that is because we'll have theta is going to be defined up top. So then we can just insert theta into the formula and knock it out. So let's do that. So I'm going to go plus or minus and start rolling out the formula as it states, 1 minus cosine, and I know that theta is going to be pi over 4 all over 2. Okay, so now we have the plus or minus sign right here, and so what we want to do is that we want to pay close attention as we start to simplify this thing out. So if I have, we got this sine of pi over 2 here, and it's going to depend where the original angle. Now the original angle is going to be the pi over 8. We know that pi over 8, it has to fall in the first quadrant, right? Because it's in between 0 and pi over 2. So therefore we know that it's going to be positive, so we can drop the negative sign and proceed from there. Okay, we still have some work to do, actually a little bit of arithmetic, and we'll see where that takes us. Okay, so after dropping that, we can just say that this is going to be positive. So I end up with 1 minus, I know that the cosine of pi over 4 is root 2 over 2, and then we're dividing this entire thing by 2. And so we have maybe a little bit of yuckiness here. And so what we can do is this. It's trying to think of a way to knock this thing out. And what we can do is that we can multiply the top and the bottom by the square root of 2, because we have a root on the bottom. We don't want this fraction right here. And let's see where this takes us, okay? So after we multiply in, right, so this 2 is going to go into each one of these, so I'm going to have the square root of 2 minus, now I have the square root of 2, so I'm going to have 2 square root of 2 here. Oops. I don't like the way this is going. Okay, so now proceeding after we drop the minus sign or the negative sign, we have this guy right here. We know that it's 1 minus, and we got square root of 2 over 2, because that's what pi over 4 is. And then we got this. So now we have some algebra to do, or I should say some arithmetic to do. And so let's go ahead and start by, and I'm going to put this up here so we might have, so if I am going to, I'm going to do this off to the side and show you guys once in slow motion. So I got 1 minus root 2, so I want to get a common denominator with that 1 so I can combine these fractions. And so I'm going to write that as 2 over 2. And so that top is just going to be 2 minus root 2 over 2. Okay? So I end up with, again, some yuckiness, but that's part of the deal. So I got 2 minus the square root of 2 divided by 2 all over 2. So lots of stuff going on with that, and it's like, oh. And just to make sure that you guys know where that came from, this part right here is this part combined up, and then of course the denominator is still the same. Now, this is going to then start to, if I'm dividing by 2 right here, so this 2 is going to be multiplied by that one, okay? Because it would be like dividing by 2, flip it, and multiply, so that would be like multiplying by 1/2, okay? And so I end up with 2 minus the square root of 2 all over 4. Now I can take the square root of 4 and the top part separately, so that's going to give me 2 minus the square root of 2 divided by the square root of 4, which is going to, at the end of the day, give me 2 minus the square root of 2 all over 2. Okay? So, the way that you can check that is that you can put this right here into your calculator and put this into your calculator, and they will come out the same. Okay? So, that's how you do that guy. And so let's take a look at how we would tackle a tangent one. Okay, so I like the tangent ones a lot more. Seem a little bit easier, and I'm going to recommend, if you can, that you use this form. It seems to be the easiest of the forms for students to go ahead and grasp and whatnot. So let's start off by finding out what theta is going to be. So we want to set theta divided by 2 equal to whatever angle that we got sitting there, and that is going to give us, let's see, multiplying the 2 up here, and that is going to be, theta is going to be 5 pi over 4. Okay, so we're going to rewrite this, and I'm going to plug 5 pi over 4 in for theta and rewrite it in our clever way, like so. And so we know that all of these, this angle right here and this angle right there, are going to turn into 5 pi over 4s, and then I just need to tackle them. Okay, so here we go. We got 1 minus the cosine of 5 pi over 4. Okay, I'm going to move this guy. Ooh, that didn't turn out well. Okay, I'm just going to erase that guy. Yikes. All over the sine of 5 pi over 4. Okay, and we don't have to worry about positives and negative signs for the original angle here, but we do have to worry about positive and negative signs when we are doing these out. Okay, so if we look, we're going to have 1 minus, okay, and the cosine of 5 pi over 4, if we recall, it's going to be over here, right? 5 pi over 4. And we got ourselves a reference angle of pi over 4. It's parked in tangentville, so both cosine and sine are going to be negative. So they're both going to give us a negative root 2 over 2. Okay. And let's go ahead and do the same steps that we did before, and see where this takes us. Okay, so I'm going to clean this up and go 1 plus root 2 over 2, because I got the negative divided by this negative root 2 divided by 2. Okay, and from here we are just trying to whittle things down and knock them out. So I want to combine these up the same way that we did in the last example, and that is going to give us up top 2 plus root 2 over 2 divided by the square root of 2, negative square root of 2 divided by 2. Okay? So now what we're going to do is we are going to let's go ahead and get rid of these fractions here. And there's a bunch of different ways that you could do this out, but I'm going to multiply the top and the bottom by a 2 here. And so those will cancel out with that and that, okay? And we are going to end up with a 2 plus square root of 2 all over negative square root of 2. And then I think I'm just going to multiply the top and the bottom by a negative square root of 2. And that should multiply that out. And that should go ahead and get rid of the square root on the bottom and give us what we need here. So putting this on into the next part, I'm going to get, using the distributive property here, I'm going to get a negative 2 root 2 minus, and then it looks like I'm going to get just 2 all divided by 2. And so, wow, it looks like we can go even further. Ooh, this thing is never ending. And we can cancel each one of these 2's out because they're in common. So I could, for example, factor out a negative 2 and go square root of 2 plus 1 divided by 2. And now that goes out, and at the end of the day, I should have this guy as my solution. Okay, wow, lots of arithmetic there. So, again, if you plug this in, and you plug this into your calculator, you should get the exact same results. Okay, and then our final example here, where we're going to just do a real quick simplification, and it looks like we have the squares of some, looks like some half angles here. So what I'm going to do is that I'm going to take the definition of these half angles right here, and I'm going to drop them in and see what shakes loose from there. So let me do that. Okay, so we square these guys up, and once we square something, this is a quality of life thing, is that if you square a plus or minus here, then those are going to go away along with the square root sign there, so we don't need to worry about those. So basically, we're going to end up bringing everything down. The 1 minus cosine theta divided by 2 times 1 plus cosine theta divided by 2. Okay, and now we have to FOIL out the top. Okay, and it's kind of like the difference of two squares, and you might have a good idea what's going to happen next here. Is that after we FOIL out the top, we're going to get 1 minus cosine squared theta all over 4. Okay, and then it looks like I'm out of room. I'm always running out of room on these things here. And so 1 minus cosine squared theta, again from the Pythagorean identity that we see a gazillion times, it seems like, that sine squared theta equals 1 minus cosine squared theta. So I'm going to substitute in the sine squared theta. And there we go, divided by 4. And it looks like that's about as far down as that we can take it. Okay, so that's going to conclude what we're doing for sum and difference formulas, double angles, and half angle formulas. And if you are going to go on to calculus next year, you definitely have to have those memorized out and how to work them and really understand where they come from, and how to rewrite them in a rewarding way. So try some of the practice that's going to follow. It might be a little bit difficult at first. Compare your answers with the answer key, and just do the best you can. If you run into a wall, you know where to ask. So that's how you do that. Now, see you in the next video.